Welcome to the program. I'm Carl Pauls. I'm here with Gabe Ignetti, Chris Bergen, and our special guest, John Van Leer of the University of Miami, is a retired associate professor of physical oceanography. Dr. Van Leer has developed new instruments and methods to measure upper ocean dynamics and bottom boundary layer structure, including organized turbulence. He's worked in the Fram Strait and Arctic Ocean on 3 expeditions measuring upper ocean frontal and eddy properties under the ice. His later work involves air-sea interactions, coastal oceanography, bubble remediation applied to oxygenation of oil spills, and catamaran research vessel design. Welcome to the program, John.
Yeah, well, that's a partial listing. There's reentry guidance system development. That was my first job in working at the MIT instrumentation lab. I'm one of the great grandfathers of Minuteman. Yeah, so that was my ticket not to have to go to Vietnam.
Wow.
Nobody had ever been drafted out of MIT instrumentation lab. It was Kennedy's administration when I was working there, and working into the Johnson administration.
Mm-hmm. Tell us about your current work, or Gabe, do you have you had a place where we were going to go with this interview?
Well, what I just to mention about one thing that I found interesting is you worked on OTEC, ocean thermal energy
conversion, yeah.
Conversion, right, which that's always fascinated me, but I don't know if it's ever going to be a real thing. I don't. You know better than me. But being an oceanographer, what is CO2? Let's start with that. What is CO2 doing to the planet in terms of our oceans?
Well, we're parking most of the CO2 we have emitted is in the ocean, as is most of the heat that comes from the global warming effects of atmospheric greenhouse gases. About 95% of that heat is in the ocean. And the atmosphere is made of air, which has almost no heat storage capacity whatsoever compared to the ocean. So the atmosphere acts as a filter for various wavelengths, and the greenhouse effect has caused the surface of the Earth to warm in a very predictable fashion. That's been known for well over 100 years that this would happen, and early calculations of how much the world temperature would increase if we doubled the CO2 were made long time ago. So this is not anything new. It's physics. It works. It's hard. I mean, you can repeal laws about emissions, but you can't repeal physics. Yeah. So it's the Earth has stored this energy, and we are seeing heat. We now have autonomous profilers that are widely dispersed in the ocean, Pallas and Alice floats that can go down to 2,500 meters or so. And so we get regular profiles of the ocean, temperature, salinity, and whatever other sensors you choose to put on these profiling devices. So the cyclotron I developed was the first oceanic profiler ever made. That was back in the early 70s. So I'm sort of the great grandfather of this too. So the profiler I made, the cyclotron, was moored and went up and down a taut wire. So it was primarily interested in looking at surface and bottom boundary layer processes and circulations within oceanic fronts, which are very important for the nutrients and upwelling systems, and upwelling systems around the world. Coastal upwelling systems specifically are responsible for about half the protein we get from fish globally. So that's why I was studying that. So the work I did during the Cold War was sponsored by the United States Navy, and we did 3 experiments north of what is Russia and the Scandinavian countries, and my work was from the Navy's perspective aimed at trying to understand the structure of the ocean as it relates to acoustics, because the principal way of detecting Russian or other submarines is by their acoustic signatures. And so the more you know about the structure of the ocean and its acoustic properties, the better able you are to detect their submarines or to mask our submarines from their detection. So there was a whole part of the Cold War, which most people have no idea about, that occurred under the ice in the Arctic Ocean. There were nuclear attack submarines operating there on the continental shelves. I had a long talk with the man who was the commanding officer of the Queenfish, which was a nuclear attack submarine, who was working there same time I was. But from my perspective, the most significant observation was the detection of ice melting when the atmosphere was down to 40 below zero. That was my moment when I understood how serious global warming is and what effect it's likely to have on the Arctic, which is heating up something like 4 times faster than the oceans generally in other parts of the world, which are also heating up, which is playing havoc with corals and other temperature-sensitive marine life. And we see a wholesale migration of fish species like cod, for example, that used to be abundant down in Massachusetts and Rhode Island and places like that, and now is migrating into the Arctic because it's become too warm down south to have a good cod fishery. I mean, there's still some residual cod, and there will probably be some genetic adaptations that will occur, but they may not be fast enough. So anyway, there was a huge hole in the pack ice. The last experiment I did was in 1988, and it overlapped the transition from the summer 24 hours a day of sunlight, and the second half of the experiment was in darkness. So we overlapped the transition, and there was an enormous hole in the sea ice cover down in south in the Barents Sea, south of us. I mean, it's way north. It's north of Norway, but that was melted by anomalously warm Atlantic water coming north into the Arctic Ocean. So it made a hole in the sea ice the size of a great lake. And that hole in the sea ice, you've heard of lake effect snow. Well, this is ocean effect snow, if you will, same principle. And so there was a storm that developed from almost nothing to hurricane intensity in about 12 hours. It was the first of the Arctic bombs, as they're now called. First one that I'm aware of. So it was, the Norwegians had never seen, usually the Arctic in the wintertime is a very quiet place meteorologically, very cold, very clear air. And this was a total anomaly. And that hurricane strength storm came up over our position. We were 30 degrees east, and we were 6 degrees short of the North Pole at 84 degrees north. So we were in deep water north of Siberia, and this hurricane strength storm blew for a day and a half at over 75 knots. And the Norwegians have been going into the ice for multiple generations, and they consulted their fathers and their grandfathers who'd been in the high Arctic, earlier, and none of them had ever seen anything like that before. And
It's amazing.
When you have a stationary cyclonic storm, it upwells deep water in the middle of the storm. In our latitudes, it upwells cold water, but in the Arctic, the Atlantic layer is about 400 to 600 meters below the surface, and that was upwelled. So the warm water from the Atlantic layer, when I say warm, I mean 2 or 3 degrees plus centigrade, mixed with the surface water, and you cannot unmix water once you've mixed it. And so that mixture was warm enough to continue to melt the sea ice from below. And in those days, the sea ice was about 15 feet thick. And now it's, like 3 feet thick. So if it is there at all, there are a lot of areas that are open water. This was multi-year pack ice, 20 and 30 years old typically. You can count the seasonal horizons by algae layers within the ice that, like tree rings, tell you one season from the next.
Chris, you have a question.
Yeah, I guess you mentioned the cod moving north, and curious a little bit about my understanding is that fish in general, a lot of species are smaller than they used to be, like a century, 2 centuries ago, the catches by fishermen. And also I'd heard recently about plankton that I'd understood that decades ago used to produce 50% of our oxygen, but because plankton has decreased in the quantity, it now only makes about 20% of our oxygen in the atmosphere. I was curious if you were aware of how much that's also affected fish having less plankton to eat, if that's also feeding in or not allowing them to grow and to recover fish species as much with less plankton in the air or in the water.
Yeah, well, the plankton, you have a food chain in the ocean, and it starts with plankton. The two big divides are zooplankton, which are animal species, and phytoplankton, which are vegetable species, if you will. And the bottom of the food chain is the vegetable species of the phytoplankton. So if you don't have as much nutrient at the surface, you can't grow as many plankton. So if you heat up the surface layer of the ocean with global warming, so it is hotter and more stable compared to the bottom waters, then you get more and more stability there's like a barrier between the upper and the lower layers, so you don't get as much nutrient into the surface layer by mixing and upwelling as you used to.
Okay.
And so that means that there's less nutrient, there's less phytoplankton, and so the zooplankton that depend on the phytoplankton become less abundant, and then the fish species that depend on the zooplankton become less abundant. It's part of the so-called trophic pyramid. So we are stabilizing the upper ocean and inhibiting the vertical mixing process as part of the global warming. And okay. That's a significant issue. And in fact, there are some areas where the mixing has been reduced to the point where you're getting anoxic zones below the surface where you didn't used to have them, because there's so little mixing that the oxygen is taken up by detritus falling through and the decay process that results as it falls through. So there's something you can think of as marine snow, which is organic material that is falling out of the surface layer. It can be fecal matter, it can be dead organisms, it can be a whole bunch of different things. And so and the good news for some of that, you're taking carbon out of the surface layer, and if it makes it all the way to the bottom, you may sequester some of the carbon that's being deposited in the ocean. But that's an uncertain process. It's one that's being studied and we don't really have it quantified very well yet. So one of the reasons why you would like to do marine science and continue to do marine science is so you can understand how these processes we all depend upon actually work.
Thank you. Gabe, you have a question.
You're muted.
Yeah. Okay. I usually mute to just in case there's noise. Yeah, actually have a couple of questions, right? The first is that we read so many, and I know that how much CO2 and greenhouse gases we put in is really up to us, so that's the main factor. But I hear like estimates from climate scientists of it's going to be mild to it's going to be catastrophic. And are those educated guesses? That's my first question. And the second question I had.
What was the question? Whether it's going to be mild or?
Yeah, the scientists. You'll have some scientists say that will be global warming will be mild and manageable. Others that say it will be, and all points in between. Others will say that it'll be totally catastrophic. And even aside from the human element in there, I mean, just how serious the projections would be. And is that like pretty much educated guesses?
Well,
Or
the guessing part comes down to what are humans going to do? How are humans going to behave? And human behavior is a whole lot more complicated than atmospheric physics or chemistry. I mean, those are complicated enough, but how humans will actually behave and what they will do, and will they do anything that resembles rational behavior, or will they do cockamamie stuff? That's a whole different. You need a psychiatrist to determine that. But I can tell you that the severity of what the global warming will be like will depend dramatically on what humans do to either accelerate it or to try to curtail it. And, we have choices, and most people are unaware of the choices that we have to make and the possibilities we have to actually make a difference. So I've been on the sea level rise projection committee for the Southeast Florida Climate Compact. They've had 2 rounds of sea level rise projection, and they assembled a group of experts, typically order of 20 individuals, and each of us contributed what we could to the projection. And the thing that makes it devilishly hard is we don't know how humans will behave in this thing. We do know some things that are quite important now that Greenland has become front and center as a source of minerals and such, and the defensive characteristic of maintaining. We've had Greenland bases forever. We had them during the Second World War. We have been welcome to maintain Greenland bases forever. But the real impact of Greenland is how fast that glacial ice will melt in Greenland. Because if we were silly enough to melt at all, that would give us a sea level rise of about 25 feet globally. So, in my view, that's a serious impact if we allow that to happen. The last time sea level was 26 feet higher than it is now, the southern tip of Florida was north of Lake Okeechobee.
And what time span?
That was 125,000 years ago. So
I'm talking about. Oh, I'm sorry.
Yeah, I mean, we've been through order of 40 ice age cycles in recent geological history, and they run about 125,000 years per cycle, and so you go through this kind of sawtooth temperature pattern where the uh, glaciers build up slowly because they're built up by snowflake falling on the ground when it gets cold and then accumulating. But you can melt ice a whole lot faster than you can form ice. So the melting process, once we get the ocean involved, undermining the glaciers in Greenland through the fjord structures like Jakobshavn and elsewhere. So the Greenland ice cap has been melting for a long time and been one of the major contributors to sea level rise. But there's been an enormous acceleration starting around 2005 to 2007 and going forward, when the warm water of the Atlantic has begun to get into the fjords of Greenland, like Jakobshavn, and that is accelerating the ice melt by putting warm, salty water under the glacier and melting it from the bottom. So these fjords have had glacial ice coming out in them forever. And, Jakobshavn, which is the biggest generator of meltwater, about 10% of all of Greenland's ice melt comes out through Jakobshavn. It's 7 kilometers wide and 1 kilometer deep. And so before the global warming signal got in from the ocean, it was moving seaward. And there was, of course, ice building up at high elevations due to snowfall. So we're not in equilibrium, but we were not melting that fast compared to the snowfall. And once we began to undermine the glaciers with the warmth from the ocean, the salty warm water, the same water mass that had triggered that storm I referred to earlier, that made the ice melt more quickly. And so the glaciers began to surge. And when they surged, they began to make seismic signals that could be detected by seismometers all over the globe. So you can study the ice movement in Jakobshavn by seismic processes, laboratory in Southern California or, any place on Earth where you get seismic data. And so you're getting seismic events up to Richter 4 and 5 on a regular basis, where we didn't get, we got a tiny seismic signals before, undetectable. And so it was a shock to seismic scientists who study mostly geophysical processes by looking at seismicity, to find that there were suddenly a whole cluster of earthquakes around the fjords in Greenland and the fjords in Antarctica.
Is that because of the thinning of the ice?
It's because of the movement of the ice. You have the center of Greenland, for example, has a height of about 2 miles of ice. And the weight of that ice is sufficient that it presses the Earth's crust down about 800 meters in the center of Greenland. Mm-hmm. And so the center of Greenland is below sea level. So if you melt the ice back with the warm, salty water, eventually you might even be able to get through flow under the Greenland ice cap, unless the ice is able to collapse fast enough to seal it. So it's the amount of water coming out of Jakobshavn in a day would supply the freshwater needs of the United States for a year.
Wow.
So there's a huge amount of fresh water tied up in the Greenland ice. And there's about 10 times more of it tied up in the Antarctic ice. So far, the Greenland ice is melting faster than Antarctica is, but that will change eventually because of the greater amount of ice down south.
So if you don't mind a little, a little side note on this, we've talked about CO2 and heat and the heat and climate effects of CO2. Have you any expertise in the effects of CO2 and carbonic acid in the oceans, and what does that have to do with our biological systems?
Well, when you dissolve CO2 in the ocean, you make dilute carbonic acid, and so the pH of the ocean is changing. And so the corals and other creatures that make carbonate shells have a more difficult time making shell. So, for example, if you like to eat oysters, the West Coast acidity in the ocean is so great that juvenile oysters that have shells that are maybe a tenth of a thousandth of an inch thick when they're the size of a pinhead, they get dissolved if they come in contact even for a short time with a higher acidity ocean. So we are affecting it. It's one of the things that the corals are having to put up with, in addition to the temperature. And of course, various kinds of coral diseases have an easier time when the corals are less robust because of they're energetically less efficient. So the corals have symbiotic algae within their each polyp. So it's like an animal that is growing a farm within it. So it's recycling the waste that the animal generates is being recycled as nutrient for these little symbiotic algae that are in the zooanthellae, as they're called. And there are many different species of zooanthellae, and those give corals their characteristic color. So that when global warming causes a prolonged bleaching event, what's happening is the zooanthellae are being expelled by the coral in a desperate last move to try to save itself. But it undermines the viability of the coral long term because it has lost this wonderful efficiency of recycling its own nutrients. And corals grow in places with very clear water, which means that they're typically very little nutrient in the water. So retaining what nutrient you can, and by means of your own little garden going in your backyard, so to speak, is a evolutionary advantage that corals have enjoyed for a long time. So there is, we mostly talk about CO2 because CO2 has a very long residence time in the atmosphere, thousands of years. But methane has been responsible for maybe 30 or 40% of the global warming that we've experienced so far, because it has a much higher impact per molecule, and that impact depends on the time scale that you choose. It's order of 80 times more potent on a molecule per molecule basis. And so the CO2 is important because it lasts forever, so to speak, in terms of human existence. Yeah. As far as we're concerned, in this present ice age cycle, it's functionally forever.
Yeah.
And the methane, on the other hand, has a high impact, and there are various sources of methane, some of which are anthropogenic. The fracking boom has been a methane leakage boom because the fracking processes are not very careful, and legacy oil wells that are no longer productive leak methane. And the way our laws run, it is the responsibility of the property owner to control the methane. And so when the property owner signed a lease allowing drilling on their land, they were looking at the big check they might get in the mail every month rather than what would be the residual methane leakage. And how would they deal with it? They probably never even thought about it. It was probably not mentioned to them by the attorneys who were shoving the piece of paper across the desk upside down for you to sign. So the amount of methane leakage from oil drilling and gas drilling and fracking particularly is growing, and the export of natural gas and the growth of that industry, which is heralded as a wonderful economic thing, may not be so wonderful in some other respects.
Yeah.
So the other thing that is terrifying about methane, and perhaps the more worrying thing, is the amount of methane that's tied up in permafrost, which is covers about 20% of the world's surface that's above the ocean. So there are big swaths of land in Siberia and northern Canada and in Alaska, and in other places. There's high mountain permafrost in the Himalayas. There's permafrost in some odd places you might not think of, but the bulk of it is in the Arctic and in Siberia, and it occurs both above the sea surface and below the sea surface. So one of the characteristics of an ice age cycle is the ocean will go, surface layer will go up and down. So the surface of the ocean will change by about 400 feet. So it's lowest during the peak of a glaciation because there's all that fresh water tied up in glaciers that's not participating in the general circulation. And there's so during the last ice age, the Siberian continental shelves were above sea level. So people might wonder, how in the world can you make permafrost underwater? Well, it wasn't underwater when it was made. And it's also very difficult to comprehend how much permafrost there is and how deep it is. I mean, it's thousands of feet deep. And that permafrost includes a lot of organic material. It includes methane, which is mostly in the form of hydrates, methane hydrates, which looks like old-fashioned moth crystals. I don't know whether you remember your grandmother's moth crystals in her sweater drawer. That's what it looks like. It's a light-colored substance, or can be colored a little bit. And if you hold it in your hand, it will melt and it will release the methane that's in it. So you can do a parlor trick of having a chunk of methane hydrate in your hand, and you can light it with a cigarette lighter, and you can see it burning off as the heat of your hand and the heat of the fire melt the methane hydrate. So methane hydrates are stable at low temperatures and high pressures. Mm-hmm. So if you go to the Arctic where it's cold enough year round, the methane hydrate only melts a little bit in the summertime normally, and it's stable in the wintertime. And in the case of the offshore methane hydrates, there is enough methane hydrate on the East Siberian shelf to warm the world significantly. So there could be a pulse of 50 times the annual output if we manage to melt a bunch of that subsea permafrost suddenly. So our global warming is not only melting glacial ice, it's melting snow that covers the permafrost that's above ground, above water. Mm-hmm. It also is reducing the albedo of the surface. So instead of reflecting 90% of the sunlight incoming from snow or sea ice, if you have a dark colored tundra, which is grows on top of the permafrost. So if you have an active layer at the surface under the tundra, which melts every summertime and turns into very cold mud. And then there's a layer of tundra, which is like sod on top of that, which is made up of sedges and grasses and a little flowering plants and even some small dwarf trees that are espaliate on the surface of the tundra. And so you have if you're up at the Arctic Ocean, the active layer might be a foot thick in the summer now. It used to be, it never melted before, but now it's melting. If you went down to southern Alaska, the active layer might be 5 or 6 feet thick that melts and thaws. And so it's very difficult to construct things in permafrost because this active layer melts and you got a sea of mud that you're working in. So when the United States and Canada decided to build a road on the interior to support the United States military because the Japanese had conquered some of the Aleutian Islands in the Second World War, they drove bulldozers north to make a road, and there are pictures of guy driving a bulldozer, and you can just see the top of his head, just sticking barely out. You almost need a snorkel to breathe because the bulldozer's heavy working in this thick layer of mud. So you got to put down a layer of gravel to act as insulation, and eventually you can build it up. If it's on sloping ground, you get movement like very slow speed avalanches because mud will flow downhill. So anyway, there are areas in Siberia that are above ground or above water, seawater, that are having explosions of methane pressure, which is blowing craters in the ground that are 100 or 200 meters in diameter from the pressure of the methane. And at first they thought there were meteors crashing into Siberia. And of course there are some meteors, but there were a lot more of these craters than there were meteors coming in. And so once they went up to study these things, there was a lot of methane vapor in the craters. And it was essentially the pressure of the methane that caused these craters to form, and it blew up the outside of the crater, so it was upset from the explosion. So it kind of looked like a meteor impact from a distance. And these things, once they form, expose the sides of the permafrost to melting. And so these things grow with time. And they expose more methane containing permafrost to melting. So there is a reinforcing feedback which is possible from this permafrost melting. So of the things that keep me up at night, those are the permafrost melting and the additional methane that would release is to me the most concerning. I mean, the other things are concerning enough. I mean, I live in a waterfront house and I have water in my street every time during the king tide season. I have a foot of water in my street.
What is your hopeful prediction? Like, if we're going to survive, what is the thing we need to do to survive as humans on Earth? How do we save Earth for the humans?
Well, we need to save it for the humans and everything else that lives here. Mm-hmm. It's a little selfish to think of it just for people. The transition to renewable energy is the key. And the good news is that we have the technology that is proven, that works, that is cheaper than burning fossil fuel by quite a bit. So you can build a new wind or solar energy source with a big-ass battery to go with it. And you can supply power for less than the operating costs of a gas-fired power plant or a coal-fired power plant. Mm-hmm. So if we don't make the transition, we're stupidly wasting money continuing to use these legacy, inefficient, fossil fuel burning entities. And we're crazy to do that. And China, of course, is building out renewable energy and batteries at an astounding scale. So they are building every month the equivalent of 5 nuclear power plants worth of renewable energy. Every month, not once in a while. And so the United States, if it wants to be economically competitive, ought to be changing to renewable energy, which is the low-cost leader, rather than wasting a whole bunch of money and a whole bunch of time and a whole bunch of real estate to sea level rise inundation that we don't need to have. So the thing that is upsetting is that in the next 50 years, people will tell you it doesn't make much difference what we do. And that is true. The solutions between aggressive greenhouse gas control and doing what we're doing now is very small in 50 years. But in 300 years, if we do our level best, we might be able to restrict sea level rise to 1 meter. And if we don't, it'll be like 10 meters and going north. So if we melt all the ice, it's 212 feet of sea level rise. If we melt everything in Antarctica and everything in Greenland, that's 212 plus whatever the thermal expansion will be. That's just the ice melt part. So the cost of adapting you can't adapt to that.
Right.
All the coastal cities are going to be toast at that stage. So
at 200 feet, we lose, at 26 feet, we're at the level of the Turkey Point nuclear plant. At 85 feet, we're at Diablo Canyon. And so, I would really like to stop it before it gets to the first one, and definitely before it gets to the second one. Let's interrogate a little bit. So you said it is the development of renewables. Why not the elimination of fossil fuels?
Well, I'd be happy. That's kind of a necessity. Mm-hmm. And in order to do that, you have to have a viable replacement.
Right.
People have gotten used to a certain level of lifestyle and energy consumption. And the thing that people don't realize that if you make the transition to an all-electric energy system, or as electric as it can be, you don't need as much energy because electric motors are tremendously more efficient than fossil fuel motors. Most of the energy when you burn a gallon of gas in your Audi is heat. It's not useful mechanical work done. So, and when you back off on the accelerator on an EV, you regenerate. So you get back about 90% of what you put in, and you can reconvert the kinetic energy back into chemical energy in a battery. And you cannot bring back the heat that you dissipate in your brake pads or your drum brakes. And of course, I've never replaced brakes. I had a Model S that I traded in after 10 years. The brakes were getting rusty from lack of use. I had to touch on them once in a while just to keep the rust off. So, the efficiency difference and the price of EVs is less than fossil fuel if you take into account the operating costs. So giving the Chinese a free rein to get way ahead of us in renewable energy isn't the smartest thing you could do. Mm-hmm. If you're competing with China, if that's your that's your concern. Yeah. Why give them an advantage like that?
And we really don't have a problem with renewables. I think it is more the exclusion of nuclear that as a group here we're a little concerned about, because of course renewables are for the next gigawatt. They are more efficient than nuclear. The question is, and you put it really well when you said it's not the next 50 years, it's the next 300.
Yeah.
So
and then we'll see the difference,
right,
of what we did this 50 years.
Right.
But you won't notice it until you get up to 200 or 300 years. Yeah. Then the difference will be astounding.
Yeah, absolutely. And so it does matter. And I think, like my personal position, we need to do everything as fast as possible. We should be building 4 to 12 gigawatts of I should say continuous 24/7 renewable energy, and that has an uplift in terms of sustainability. If right now we're backfilling it with more methane, that is a big climate problem itself. And so will batteries scale up? We don't know. And so
only if we scale them up. If we don't scale them up, they won't. If we do scale them up, they will.
Yeah.
and it's cheaper to scale them up than what we're presently doing. So you can't tell me that it's not economically doable. That's nuts.
I think that with nuclear, batteries and renewables become better.
Well, nuclear should be, we should keep the nuclear that we have.
Right.
You know, if it's working and it's making power and it's not emitting, we should leave it alone. But it is so much cheaper to make renewables than nuclear.
For now.
I can't even, forever.
Well, okay. Well, the problem is, and this is a larger argument, but the problem is that if batteries don't scale, if they
what do you mean if they are scaling? I mean, don't scale? Are you kidding me?
Oh,
are you
what's
nuts?
the energy? No, absolutely not. What's the energy density of a battery? And how much? And you know how much?
There's plenty for stationary storage.
Not,
I mean, there's
not
no
months,
problem.
right?
Not for months. I'm not
for months.
following you.
Oh,
What are you saying?
Fossil fuels keep for months. Fossil fuels build up for months, and right now, we're working on a fossil fuel system, which is seasonal in its cyclic nature, right? The energy.
Yeah. What does that have to do with batteries? I'm not not following you.
Everything, because the difference in energy consumption between summer and winter is enormous. And so the buildup of energy storage from one to the next, and from what we see in Germany is called the Dunkelflaute, is the period of low sunlight in simultaneous occurrence of low wind energy, will last 10 to 14 days.
Yeah, so you need to have 10 to 14 days worth of battery storage.
And so far,
or you need to have electrical cables to bring the electricity from the Sahara or from the hydroelectric of Norway or wherever it is. I mean, you need about 3 times your daily output in general. I don't know if you have looked at Rethink X.
Yes, I've actually had a debate with someone on Rethink X and the related studies. This is the energy transmission from the North Sahara to Europe. It is a great project. It is not as onerous as, let's say, the transmission from Australia to Southeast Asia, which is a much more difficult project, and it is much simpler than the enormously difficult plan to interconnect North and South America for similar energy transmission.
Well, that wouldn't be necessary. I mean, the geothermal power output of a number of regions will be very useful to help tide you over.
Right.
And there's geothermal potential everywhere. It's just a matter of drilling a little deeper. So, I mean, it's not like there isn't hot rocks down there. There's plenty of hot rocks.
What we find is that the problem with the current investment in geothermal is that it is largely powered by fossil fuels. So we do need to get a clean grid before we can take advantage of a low CO2 geothermal, unfortunately.
I don't understand that.
So if we look at the UNECE, and this is I understand we're well outside sort of your experience, and so we might be citing a lot of stuff.
Yeah, I've been working with geothermal stuff for a long time. I've taken classes to Iceland to see what they're doing, and we have a lot of geothermal in California. There's tremendous geothermal. We haven't even begun to develop the geothermal that we have, and that's 24/7. There's hydroelectric that's 24/7. There are a lot of ways of storing energy besides batteries that can complement it. So the renewable energy transition is mostly going to be limited by how fast we can ramp up battery storage.
Right.
And that's happening at an extraordinary pace. It needs to accelerate more. It's not fast enough, but we know how to do it. It's just a matter of turning the handle. It's not rocket science. I did that. I know what rocket science is. That's hard.
Yeah. And I think that, when it comes to our position, yes, do all of this and also have a minimal investment in nuclear, because nuclear makes your batteries better. Nuclear drives fossil fuels off of the grid just as well as renewables. And in 50 years, you will start to see the benefit.
Well, the nuclear power has long life waste products that we have not figured out what to do with yet.
And it
has an. Well, I mean, they're being stored on site at Turkey Point. So if we ever have a nuclear accident or some terrorist blows up Turkey Point, we're gonna feel that all over the general area. I mean, that's not been solved.
If an airplane crashed into the dry casks, you would have a broken airplane.
Yeah, but if a terrorist put off a bomb inside that, I don't think it would be so good.
If they exploded a bomb sufficient to break the reactor,
well, break the storage ponds. They don't have to get the reactor; they just need to get the fuel rods in the storage ponds.
You would have a low-level local meltdown, not sort of a regional
No, it'd be an aerosolized dispersal of radioactive material.
And that radioactive material decays, and then dangerous things decay
in thousands
quickly.
Of years. Yeah,
it really depends.
A few decades.
Yeah, it is.
Worst stuff.
It is fantastic to think of the kind of scenario where this would be, and we have had accidents in the U.S. where we've had exposures to the public. We've had, in my own backyard, we had a cesium device that was split open accidentally, and monitored and contained, fortunately. And that's in a 40,000 people per square mile, dead center of the city. And so the fantastic alternative to Turkey Point is okay. So say they dry up the fuel storage tanks, which are full of water, and so there's one bomb to do that, and then you let the terrorists come back and then blow up and aerosolize the fuel stacks after the water has gone.
Well, it depends. Yeah, it depends on the size of the bomb.
Right.
I mean, you can do that with one bomb, I would point out.
Big enough, absolutely. And then you would have the problem of that one bomb.
Yeah. Well, you'd have the problem of the dispersed material too. I mean, it's basically enclosed in something like glass inside of a metal container, but you can. Well, it's a good thing I'm not a terrorist. Let's put it that way.
Right.
I'll agree with that.
Gabe, you have a question.
Yeah, well, more of a comment.
Okay.
For one thing, they're so strongly built. I mean, the caskets could withstand a freight train with cosmetic damage hit. It's been done. You can see that on YouTube. Same thing with a jet collision. It's damn hard for
Fighter jet collision
to
fighter jets.
bomb anything. And I would add to this, I honestly don't see any nuclear accident except for Chernobyl to have really been objectively serious. It was more from the panic in Fukushima, the zero radiation casualties in Fukushima. I think it was under 100 for Chernobyl, in spite of how severe it was, which is one on. So even if the terrorists got away with all of this, it would be, to me, I think it would be a tempest in a teapot, going by the results of what's already happened. And I would just add one more thing. As far as the batteries go, the more you put on, the less they get used, because they're there for like rare occurrences. You're much better off having some kind of a power source that could ramp up. And hydroelectric, I don't think so. There's already been problems with droughts and China that has caused heat waves and no electricity at the same time. So it's not as reliable as I would think.
Yeah. Well, the battery business is not I grant you that the United States has done its best to slow it down in the United States, but elsewhere in the world where we've had a more friendly background. I mean, the Chinese are eating our lunch in the battery business. I'll give you that, but that's not because Chinese are inherently smarter than we are. I mean, we can make batteries too, as well or better than. And so there are now hundreds of research groups around the world who are working on improving battery technology, improving solar technology, improving geothermal technology, improving. So the amount of effort that's going into this is outstanding, and the amount of results are far going to outweigh what we can do short term with nuclear power, which takes often a decade or more, and usually costs 2, 3, 4, 5 times more than the initial estimate is, and that doesn't include the insurance policy of dealing with the radiation if you did have an accident.
Well, let's correct that, because we can't really have misinformation. So insurance from nuclear is funded in multiple stages. Now, of course, the first stage is $1 million insurance premium that the operator pays.
Yeah.
That's underwritten, insured by Lloyd's of London. So it is not true. Some people may say that you can't insure these, and it has to have the government. And then there is, of course, a law that organizes how an overage would occur. So if there is a overage, then it goes into a fund. And that, I forget the name of the fund for a moment. Someone, Gabe or Chris might, or John, you might remember. And part of this fund was used to compensate the businesses that were impacted by the evacuation around 3 Mile Island. So we paid about $40 million from this fund, and it has billions and billions of dollars built up as a liability pool for a major disaster in the U.S. And as well, if we exceed that liability pool, the nuclear industry itself is to be tasked.
And the federal government is the ultimate.
Right.
We're all on the hook.
Well, the federal government is of course on the hook for Superfund sites, which are largely fossil fuels.
Sure.
And so this is the consequence of all industrial activity, is that the federal government is the ultimate arbiter of
absolutely
when an accident happens, is paid. So, but nuclear is only slightly different than that, in that the nuclear industry pays a very large upfront premium and has laws that structure overages from that premium. As you said, fossil fuel drillers will walk away from a methane well and let
absolutely
it leak. So,
yeah, that's the way it works, and our property laws are set up to do that, that kind of thing. Excuse the offender and make the property owner pay the freight.
Yeah.
So that's the economics of renewables are so much better than nuclear. That's a huge difference. And so I would hope that we would scale renewables faster than would be limited by scaling nuclear. That's going to be too slow, too late.
I really want to push back on why make it nuclear versus renewables, because even with renewables scaling as fast as possible, we still have fossil fuels on the grid. We have, at least 75% of all of our energy produced globally coming from fossil fuels, and we should reduce that as fast as possible.
Sure, absolutely. I agree with that.
So, John, I did drop a link to the UNECE, and this is the life cycle assessment, and you'll be able to go through this on your own. We don't really want to, try to pin you down on this right now, but this is sort of the latest of how each energy source under the current energy mix. So geothermal could, in a closed loop with clean energy, maybe it gets much better, but at this time it's very dependent on fossil fuels, unfortunately.
Well, yeah, I understand that, but that's a political decision, and it has to do with the political strength of the fossil fuel industry. Having spent time on Capitol Hill, I'm very well aware. And if Elon Musk wants to reduce government expenses, if they would just take away the fossil fuel subsidies, that would leave a lot of money to do everything that we might want to do. So we're spending billions of dollars, trillions on a global scale every year subsidizing fossil fuel. And, we need to put a price on carbon so that we can begin to have a level playing field. I mean, the subsidies for fossil fuel are eye-watering, both nationally and globally. That is the fundamental issue.
Yeah, I think that a carbon tax, especially a border-adjusted carbon tax to prevent, if America, under the current administration, wants to get away with a no carbon tax, then we will be facing strict tariffs everywhere that has a carbon tax. And we should definitely consider that. And then if you want to get rid of the tariff, pass your own carbon tax. It's as simple as that.
Yeah. Yeah, the carbon tax needs to be paired with a refund policy so that the ordinary people are not disadvantaged or forced to suffer when you make the transition. They should be made whole.
I remember in Washington in 2015, we had the opportunity to do this. We voted down the carbon tax that would directly rebate our sales tax, and it was awful to see that fail. I think that we definitely should consider something like reducing sales tax across the board in the U.S. That would uplift everyone, and trading that for a carbon tax seems like a decent trade for me right now.
Yeah, no brainer, and you'd reduce the healthcare costs if we would reduce carbon consumption.
Yeah.
Okay. Well, I'm. You might imagine I'm not a great enthusiast for nuclear. One of the advantages of ramping geothermal is the same drilling technology, which is useful for extracting fossil fuel, can be used to extract geothermal energy. The same casing, the same drill rigs, the same pretty much everything. And even fracking is used in geothermal to split the hot rocks apart to increase the heat transfer. And with geothermal, you have if you do it in a basaltic environment, you also inject CO2, you make carbonate in situ. So you do some serious geological sequestration as part of this process.
That's true, yes.
So anyway, I'm encouraged about the future. Renewables can do it coupled with batteries, and the mix of wind or solar depends on where you are as to what is the more. And any energy source that's non-polluting is probably a good one. And if you have nuclear power plants, for God's sakes, don't take them offline. Use them. I'll go that far.
We welcome it. We welcome it, definitely. Thank you so much for your talk, John. This has been the Eco-Modernist Channel Live. You can find us every Sunday at 10 a.m. Pacific, 1 p.m. Eastern, right here on YouTube at Eco-Modernist1 or the Eco-Modernist Channel. You can find us online at esna.earth. That's esna.earth. Please find us on Patreon at the Eco-Modernist Channel to support our work, and find us on Facebook at the Eco-Modernist Society of North America. I'm Carl Pauls. My personal channels also rebroadcast this. You can find those on x.com/CarlAlexPauls and on Twitch, Soyaddle or soyaddle.tv. And remember, emissions first, peace and justice will follow.
Please subscribe to us on YouTube,
EcoMonitor channel. Also to subscribe to us on Twitter and Facebook, EcoMonitor Society of North America.
And online at https://esna.earth.